Alright, now we're going to take it to the next level, and we're going to set up a way to have any spreadsheet, in particular now this is Excel, to create us the best fit line. So first we're going to create a new column, and we're going to call it residuals. And oops, I spelled it wrong. Residuals, so I want residuals. There we go, hit enter. And what is a residual is the difference between the fit line and the data. So we're going to plot now equals, and we're going to say the data here minus the fit, and hit enter. Okay, so then we are going to then fill it in just like we've done before with the drag handle. Get a bunch of numbers there, and I'm suspicious, but we will just make sure and format this. Number, 2 decimal places, fine. It could be because these are both 2 decimal places, the data and the fit line. And now we are going to graph this to have a look at it. Right, so we're going to pick our X values. Now we're going to try something new. We're going to hold down the control key, and this is also a new way to make a graph. We're going to hold down the control key, and oh, I did a little wrong. We're going to select the X values, right, like this. And now I'm going to hold down the control key. Now I'm going to click on residual and drag down. So notice I'm selecting data now that's not right next to each other. That's what the control key does for us. I'm going to go back to the insert tab. I'm going to pick a scatter plot once again, and there we go. And now we're going to have a look at this. Alright, so in general, if you think about it for a minute, the residuals, if we have a good fit, they should all be 0. If your fit line is perfect, the difference between the fit line and the data would be 0 every single time. And we notice this one not only isn't perfect, it's pretty weird looking. Well, there's a couple things going on here. Number one, the data I created is artificial, but that's a different issue. But let's do a little change here. We're going to go into this y-axis, and we are going to say that we want to change. We're going to go click on it, and we want to pick axis options. The bars over here on the right, axis options, and we're going to say that the y-axis is going to go, let's say, from a -2 to a +2. There we go. Even though we did lose some dots, it's just easier to visualize, and we want to focus on anyway it equal to 0. So what we can do is we can say we know that this fit line already, we can see it's not so great. So let's put the intercept back to 0 and go, wow, now that's kind of nice, because now we see that at least they mostly go to either side. And so we can say now 9.7, and that's too much below. So why don't we try 9.65, and boy, well, 9.65, not 85, and it's starting to get better still. Okay, so now that's suggesting to us that this residuals might be a good thing, and in fact we can take this one step further. So I notice now, we're going to add something here at some point. So I'd like to keep a blank space there. So watch what I'm going to do. I'm going to click on this F here, select the whole column. Then I'm going to right mouse click in here. I'm going to say insert, and it just inserts another column. Huh? Okay. So we are going to create what's called the sum of the residuals. So we're going to go to insert menu, and let's find symbols. And I've already got it here, but we need Greek symbols. This is not that big of a deal, but it's just easier. It looks cool. Well, I don't. Here we go. Greek extended. Let's see if that gets us all. Well, we don't want to spend too much time here. So I don't see the Greek letters right away. So what? We're gonna say then here. We're gonna cancel this. We're gonna call it the sum of the R's, the residuals. Alright, so now we select this and we're going to say equals SUM, and then we're going to open a parentheses. We're going to select the residuals, and then we see it up here in the formula bar. We close it and we hit enter, and there's going to be a number there. So now we can start to play with this some more. And what about 9.67? Whoops, went off. See, they went off because I typed the wrong thing. 9.67, and oh well, it got smaller. So that's this number went from -5 to -8, and we want it to go to 0, 9.66, and it got a little smaller, 9.65. Oh, that's not so good. Well, 9.65, it's getting smaller, 9.64, smaller still. So it's getting to be better and better. Let's try 9.62. And nicer and nicer. It looks pretty nice. Alright, so now I'm going to demonstrate to you, though, that it has a little bit of a shortcoming. So what I can do is I can make this 20, and it goes way off. But let's make the y-intercept -10, and now you can see that getting smaller, -20, and smaller still. And let's see what happens with -25. Ooh, so -27. Oh, it got bigger. -26. Wow. Now look at that. Now I'm much smaller than I used to be, but that fit is terrible. So this is not really the best way to do it. And yeah, of course we can use our eyeballs and we can get it pretty close, but I'm going to show you now how to make a better number. And what it is called a chi-square. So chi raised to the second power, chi-square. Type it in up here. And what is the chi-square? So the chi-square is equal to the residual squared. So it's going to be, let's see, there's different ways of doing it, but we can click on the residuals, and we say raised to the 2 power squared, divided by the error on that point, and also squared. Now one problem here is, of course, this is going to give us a very strange okay, so there is in fact some value there. So that was so small, but it shows a 0 here. So what we're going to do is we're going to format here. We're going to make this 4 places so we can see all of them. Aha. Alright, so that's a huge number, but you see there's a big difference, and let's not worry too much. So fill this in. Now I got a series of numbers. Now notice they're all positive. In fact, what happens is this thing now becomes something of a parabola, and that's pretty cool because we can graph this. Let's graph the chi-square, and here's a scatter plot, and wow, that looks really funky, and I wouldn't worry too much about that yet, but let's save it. We'll look at it a little bit later. Oops. Alright. Anyways, now the next thing we need, just like we did the sum of the residuals, we need a sum of the chi-squares. Sum. Because what will happen is, as the fit gets better, just as the residuals would go to 0, so would the chi-square go to 0. Okay, so this is going to equal sum of these numbers. The thing with this one, though, is that since they're all positive, we can't actually get it to go to 0, but we can just make it go to the smallest possible number. Could it be 0? Yeah, they could all be 0 if we can make a perfect fit, sure. Alright, so now I get this monster number. Notice that since the r's can be 0, though, negative, when we sum them, the bad negative ones, can be hidden by bad positive ones. Whereas with the sum of chi-squares, if some of them are bad, well, that's that, because no way can they be hidden. Okay, so let's start plotting this. Let's make this 0 again. Let's see. So the chi-square got smaller. Okay, let's make this 10. Chi-square got smaller again. Now, what happens is, even though the really stupid numbers before made a beautiful residual number, the chi-square was ridiculous. Now, once again, if we have our eyeballs to help us, this is no big deal, but what we like to do is we'd like to use a computer to do this for us, and a computer doesn't have eyeballs, so we can only tell the computer to vary these numbers and then watch the chi-square and the sum of the chi-square and make it as small as possible. Now, the reason we divide by the error is because we know that if our fit line can have more freedom if there's more big fit, the error bars are big, and we'll notice that the chi-square numbers with the big error bar, like this one, are very small because they don't contribute much, because so they don't have much effect on the sum of the chi-square. So now, just short of having the computer do the fit itself, which we can go over another time, you have everything you need to draw a graph, add the error bars, and then you can make the best possible fit line just by using your eyes. Oh, and by the way, let's take a look at the chi-square. And yeah, some of them I guess are really big. It's too bad that this should be a parabola, but we can pull that out. We can just click here, and let's make this say, I don't know, let's make it 10. And I think we'll see. Yeah, see, now you start to see the parabolic shape, and we can mess with that until it's perfect parabola. But this is a little deeper, and in fact, what you have to do is you make the chi-square not as a function of x, it turns out. You make it as a function of the various m values that you could pick in the various y-intercept, but that again is beyond the scope right now. Alright, so there we go. See you in class.